How modern time fragments the body. Time used to move in blocks. Morning ended, night arrived, work stopped, rest followed. The body learned these rhythms long before clocks existed. Modern time works differently. It is continuous. Notifications blur hours. Tasks overlap days. Nothing clearly begins or ends. And slowly, this is fragmenting the body. The fragmentation is not metaphorical. It is physiological, a disruption of the temporal architecture that every biological process depends on to function correctly. Researchers studying longevity noticed a striking pattern. People living in highly fragmented time aged faster, even when their lifestyles looked healthy. The issue was not stress intensity. It was temporal confusion. The body was not being overwhelmed. It was being disoriented, receiving a stream of signals so irregular that the systems responsible for timing repair, hormone release, and immune function could no longer calibrate themselves. When time loses structure, the nervous system struggles to predict what comes next. Effort might resume at any moment. Recovery becomes provisional. The body stays alert, waiting. The waiting is not passive. It is metabolically active, a state of readiness that consumes resources without producing the recovery that those resources would otherwise support. Biologically, this state is costly. Stress responses flatten. Hormonal cycles lose contrast. Repair pathways hesitate, unsure when they are allowed to engage. The systems that govern maintenance operate on the assumption that time has a shape, that there are predictable intervals of effort and predictable intervals of rest. When that assumption is violated, the systems lose their calibration. What made this dangerous was subtlety. Fragmented time felt productive, flexible, efficient. Few recognized that the body was paying a price for the constant switching. The price was hidden in markers that most people never measured, visible only in the slow advance of aging indicators that seemed premature given the person's habits and circumstances. Tasks no longer ended. They paused. Attention fractured. Presence thinned. The body adapted by remaining partially activated across the entire day. The partial activation was the body's compromise. Unable to determine whether effort was over, it chose to stay ready, sacrificing the depth of recovery for the speed of re-engagement. This explained why fatigue increased without obvious overload, why sleep no longer restored energy, why aging markers drifted earlier than expected. The fatigue was not the result of too much work. It was the result of work that never achieved closure, activity that the body could not file as completed and therefore could not recover from. The body evolved to live in chapters, not streams. And when time stopped offering chapters, biology began aging as if the story never paused. That fragmentation did not announce itself. It accumulated quietly, hour by hour, until resilience began to slip. As researchers examined fragmented time more closely, they found that the body treated constant switching as a form of stress. Not dramatic, but persistent. Each transition between tasks, however minor, imposed a biological cost. The disengagement from one mode of operation and the re-engagement with another. Every transition carried a cost. Shifting attention, reorienting goals, re-engaging effort. In fragmented time, these transitions multiplied without resolution. The system stayed in preparation mode. The preparation was continuous because no single mode of operation lasted long enough for the body to settle into it. And the perpetual transition state consumed the recovery intervals that would normally have appeared between sustained efforts. Biologically, this altered recovery architecture. Cortisol no longer rose and fell predictably. Sleep cycles fractured. The deepest phases shortened, cutting off cellular repair. The architecture of sleep depends on the body entering rest with a clear signal that the day is over, and fragmented time does not provide that signal. The body enters sleep in a state of partial readiness, and partial readiness produces partial sleep. What surprised scientists was how little pressure was required. Even low-stakes tasks, when scattered across the day, produce the same aging signals as heavier workloads delivered continuously. The findings suggested that the cost was not in the tasks themselves, but in the transitions between them, and that the number of transitions mattered more than the difficulty of any individual task. The problem was not work itself. It was interruption. Effort never reached a natural end. Rest never reached full depth. The cycle of engagement and disengagement, which the body relies on to time its maintenance processes, was replaced by a continuous low-level oscillation that satisfied neither the need for effort nor the need for recovery. People believed they were resting because activity slowed. But the body knew better. Anticipation remained. Attention stayed partially open. Repair waited. The gap between subjective experience and biological reality was the same gap that appeared in every study of fragmentation. People felt they were pausing, while their bodies registered no pause at all. This explained why weekends often failed to restore energy. The schedule changed, but the structure did not. Time remained fragmented, just rearranged. The rearrangement changed which tasks occupied attention, but not the quality of the temporal structure surrounding them. 2 days of differently fragmented time are not the same as 2 days of contiguous rest. In contrast, individuals with contiguous time blocks age more gently. Effort clustered, rest clustered. The body could read the rhythm and respond. The clustering provided the temporal contrast that the body uses to distinguish effort from recovery, and that contrast was the essential ingredient that fragmentation destroyed. The data pointed to a clear conclusion. Longevity depends not only on how much we do, but on how time is shaped around what we do. And in a world that prizes flexibility, that shape has quietly collapsed. The conflict becomes clear when fragmented time is mistaken for freedom. Flexibility promises control, the ability to do anything at any moment. But biologically, this creates uncertainty. The nervous system cannot distinguish between freedom and unpredictability, and it responds to both with the same heightened vigilance. The nervous system evolved to read patterns, clear signals of when effort begins and when it ends. Fragmented time removes those signals. The body stays alert, unsure when it can stand down. The alertness is the body's default response to temporal ambiguity, a conservative strategy that protects against being caught off guard at the cost of preventing deep recovery. Researchers observe that people living this way rarely experience full recovery, even during inactivity. Their systems never fully disengaged. Stress responses overlapped. Repair pathways remained secondary. The observation held even when the total amount of rest was adequate by conventional measures, confirming that the issue was not quantity of rest, but quality of temporal structure. Attempts to solve this often focused on efficiency, multitasking, faster switching, better tools. But these intensified fragmentation. They increased transitions without restoring closure. Every tool that made switching faster also made it more frequent, and frequency of transition was the variable most consistently associated with accelerated aging. What restored biological balance was not doing less, but grouping more. Clustering effort, creating uninterrupted blocks, allowing tasks to fully conclude before moving on. The grouping reduced the number of transitions per day, and the reduction allowed the body to settle into sustained modes of operation long enough for the systems that depend on continuity to function. When this happened, biology responded quickly. Sleep deepened, stress markers dropped. Aging slowed, not because life became easier, but because it became readable again. The readability was the mechanism. The body did not need less to do. It needed clearer signals about when doing was over. The conflict, then, is not between flexibility and rigidity. It is between fragmentation and coherence. Longevity suffers when time loses its shape. And in cultures that celebrate constant availability, that loss of shape has become the norm rather than the exception. The climax of this story is the realization that the body does not age faster because time moves quickly. It ages faster because time becomes incoherent. When days are broken into fragments, the nervous system never fully exits readiness. Repair is delayed. Resilience thins. Aging accelerates quietly. The resolution is not to control every minute. It is to restore continuity, blocks of effort, blocks of rest, lives with discernible chapters instead of endless switching. The restoration does not require rigidity. It requires intention, a deliberate choice to protect the temporal structure that biology depends on. Longevity thrives on rhythm, engagement followed by disengagement, focus followed by release, time that moves forward but also pauses. Modern life often mistakes fragmentation for efficiency. Biology experiences it as instability. When time regains its shape, the body relaxes its guard. Recovery deepens. Aging softens. Because in the end, the body does not ask how busy we are. It asks whether time still makes sense. Subscribe to join the journey. How